Hey everybody, I'm Reality Rick and welcome to Geek Frustrations. The good thing about starting with Java as a programming language is that it's practical. Lots of people are using it. The downfall is that it's an object-oriented language and it takes a bit of understanding to really get your feet wet. So I'll try and make this brief, but the introduction is going to have to be a little bit theoretical. Now the real key to what's going on in object-oriented programming is something called abstraction. Abstraction refers to different levels of thought. So think of a car. A car has many different components. On one level of thought, this car is a butt delivery device. It gets you from point A to point B. You don't have to care how it works, what's under the hood, or what's powering this thing. You simply get in the seat and you turn the ignition and it takes you there. That doesn't mean that what's under the hood is unimportant. Everything has to be working perfectly in order for it to get you to where you want to go. So what's under this hood? We open up the hood and we see that it's made out of other components, like pistons and spark plugs. Well, what's a spark plug made out of? Well, if we open it up, we see it's made out of other components. Each time we look deeper into what it's made out of, we're moving to a different level of abstraction. Object-oriented programming works much the same way. You have an object that behaves a certain way. Once you get it to work the way you want it to, you can forget about all the inner components and how it goes. This allows us to develop programs with enormous complexity. The human brain can only handle so much at once, but you can compartmentalize it, that is, put it into a package, and put it into a corner of your brain and kind of forget about it for a little while. You only think about it when you have to. Now let's have a look at this object called an applet and see what's going on. In this code, first two lines are bringing in functionality. Functions from the swing components and the AWT components. We don't have to go into great detail here because you'll be using quite a bit in the future and you'll become familiar with them as time goes. But all you have to know for now is that there's pieces of code in there that accomplish certain things for you. All you have to do is write the name of their code that they have written and it will do its job. There's actually quite a lot going on in the next line of code here. First of all, we have an object or a class, it's the same thing, called JHello. This JHello is a name that we've made up. It can be anything you want, as long as it doesn't interfere with another name that Java has already made. Our class, or object, is a public object, which means when other people write code, they can access it and utilize what you've written. You can also write another kind of object that is private, where only certain components or certain other objects that you've designated can use it. Other people writing code will not be able to use what you've written. This is not meant as a security feature or some kind of encryption to hide from someone else. This is useful in abstraction to help you think about how your components go together. Now the last part of this line extends JApplet. JApplet is something that the Java group has made. This object that we are making, called JHello, is an JApplet. What this means is our JHello carries all of the components that JApplet is made out of. It's available for our use. What we're doing with the rest of the code in this object is we're specializing. We're using JApplet as a model, a mold. We're going to specialize and shape it to fit our specific needs. This would be like taking a car and adding a new engine to it. We can override the engine, pull the old one out and replace it with what we've made. We can put new seats in it. We can give it new paint. All of these are changing the properties of a car. This is behaving much the same way. We are changing the behavior of a JApplet. but other things may remain the same as the original. So let's have a look at what we've changed. The next two lines of code here are adding properties. So the first thing that we add to our Applet is a container. This container is called con. That's the name that we've given it. So we're putting a container inside our special Applet. What this next part of the line does is initialize or set up or start our container. This would be like putting gas in the car so that the car is ready to go for the customer. The next line operates much the same way. We are getting something called a JLabel, and we're giving it our own name. We're naming it greeting. This is so we can tell the computer which JLabel we're referring to in the future. This new line tells the computer to get new memory, to get a space to put this JLabel. We'll go more into dynamic memory and creating new memory in the future. This is another complex topic, but unfortunately necessary in this particular case. So we're just going to take it as is, and I'll describe it in a future video how it's working. So within this new memory that has this JLabel that we created, we are going to initialize it or start it out with a string that says hello world. That's like deciding to put supreme gas in the car instead of regular gas. We're just specifying what to put in it when we create a new one. Last piece of code called a block. This is a function. This function is called init or initialize. Every object must have a way to initialize or a way to start up. What does it do when it first starts to exist or comes into being? In our case, we've overridden or replaced that function with our own. This line of code gets a container and adds a label to it. Not just any label, but the one that we created called greeting. If you remember, the greeting has the hello world already in it. So now, when the program runs, it's going to put all of these things into memory, and it's going to put hello world into our initialized container. By default, when we run the app, it's going to display itself and show us this label. Run as Applet, and as we saw in the last video, we bring up this window which is created by our runtime environment. Inside the window, we have our applet, as we can see here. And our applet has a label which says hello world. All of this is displayed to us by code created by the Java group and that we've included into our applet. All of these components are quite complex, and I'd rather not start in a complicated side of it. I'd rather break this down into small individual pieces that we can easily understand. So in the next video, we're going to go into something called primitives, and we're going to talk about primitive data and how it operates within our applets or our applications. See you next time.